Hi everyone! Today we'll explore the rate of change using a real-life example, the melting ice cream. Let's dive into how differentiation helps us understand how quickly things change. But before that, here are the members of our group who contributed to this presentation. Now let's dive into the core concept, differentiation. Differentiation is a key topic in calculus that helps us understand how things change. It's used to calculate the rate of change of a function, showing how one variable changes in relation to another. For example, if we have a function f of x, its derivative, written as f prime of x, or the derivative of f with respect to x, tells us how f of x changes as x changes. This rate of change can be used to understand how fast something is changing. A simple example would be the function f of x equals x squared. The derivative is f prime of x equals 2 times x. This shows us that the rate of change of f of x is 2 times x for each value of x. Now that we understand the basics, let's explore the applications of differentiation. The first application is rate of change, which helps us understand how quickly a dependent variable like height or volume changes as the independent variable like time or distance changes. For example, when ice cream melts, we can use the rate of change to determine how fast its volume or radius is decreasing over time. That's exactly what we'll explore today. We also use differentiation in optimization, where we find the maximum or minimum values of a function like maximizing profit or minimizing costs. We do this by setting the derivative equal to 0 and solving for the critical points.
A large scoop of ice cream melts in the shape of an inverted right circular cone. The full cone has a height of 15 centimeters and a base radius of 5 centimeters. As the ice cream melts, both the height and radius of the melted part decrease, but the cone retains its shape. This means the ratio between the height and the radius remains the same throughout the process. At a particular moment, the volume of the remaining ice cream is decreasing at a rate of 12 cubic centimeters per minute. In this problem, we will explore the following questions. First, we will express the radius of the melted ice cream in terms of its height. Next, we will form a volume equation involving only the height of the melted ice cream. Then, at a specific moment when the height is known, we will calculate how fast the height is decreasing. Finally, we will also find out how fast the radius of the melted ice cream is changing at that same moment.
Let's solve the problems together. Question A. Express the radius r of the melted ice cream in terms of its current height h. Since the cone maintains the same shape, the ratio of radius to height is constant. Therefore, r over h is equal to 5 over 15, so r is equal to 1 over 3 times h. Question B. Show that the volume V of the remaining ice cream is given by V equal to pi over 27 times h cube. Volume of cone is given by V equal to 1 over 3 times pi times r to square times h. Then substitute r equal 1 over 3 times h into the equation, and we got the answer V is equal to pi over 27 times h cube. Question C. When the height of the melted ice cream is h equal to 6 centimeters, calculate question 1. Find the rate at which the height of the melted ice cream is decreasing, given dV over dt equal to negative 12, by using chain rule, dV over dt equal to dV over dh times dh over dt. So dh over dt equal to dV over dt divide by dV over dh. From B, V is equal to pi over 27 times h cube. Find the derivative of V with respect to h, and we got dV over dh equal to 4 times pi. Then substitute the value of dV over dt and dV over dh into equation 1. Then dh over dt is equal to negative 0.955 cm per minute. So, the height is decreasing at approximately 0.955 cm per minute. Question 2. Find the rate at which the radius r is decreasing, by using chain rule dr over dt equal to dr over dh times dh over dt. Recall from A, r equal to 1 over 3h, then the derivative of r with respect to h is equal to 1 over 3. Substitute the value of dr over dh and dh over dt in equation 2, and we got the answer, which is dr over dt approximately negative 0.318 cm per minute.
For the integration of artificial intelligence in this assignment, we used 4 tools. First of all, ChatGPT is used to generate a sample problem. The prompt used is, give me sample problem of rate of change, and divide the problem into many questions such as A, B, and C. Secondly, we uploaded the solution to Perplexity AI and asked it to solve it. The steps shown before is the result. For the voiceover, we used Microsoft Clipchamp as the tool. We wrote out our script and let the AI do the talking. We set the language to be in English, United States. Lastly, the slides are made based on a template on Canva.
Hi everyone, I'll be explaining how we planned and produced our video for this assignment. We started by discussing the project and divided the tasks based on each member's strengths. Nisa did the group introduction and explained differentiation. Sabila created the AI prompt and introduced the problem. Afi defined variables and solved the question step by step. Nawfal explained the AI tools we used. Ameline handled the planning and video making process. Alia compiled and edited the video. And Aziza created the Google site and documented our tasks. Each of us designed our own slides using Canva, recorded our screen, and added a voiceover. Then we sent our parts to Alia, who compiled and edited the final video. Aziza uploaded everything to a Google site, including the task list, explanation steps, and final video. Overall, everyone did their part well. With good teamwork and planning, we managed to complete the project on time. Thank you.